welcome to our fourth video in R programming. So we will continue first by discussing a few things about matrix operations in R, and then we will move on to the array operations. So as you can see in this example, we can create our matrix A using the rbind function as we did in the previous videos. You can check the previous videos if you didn't. And we have the column bind also function in R. So we can construct these matrices. So let's try. As a result, you can check. This is our matrix A. And we can create another matrix for example, and now our matrix B is something like this. So in matrix multiplication, we know from linear algebra the dimensions must match, right? So if you want to check the dimension of A, you can use the dim function. Dimension of A, it's 2 by 3, so we have 2 rows and 3 columns in this matrix. And for B, the dimensions are 3 by 2. There are 3 rows and 2 columns. So we can multiply 2 by 3 matrix with 3 by 2 matrix. And the result, as we know from linear algebra, is going to be a 2 by 2 matrix, right? And in R, we do the matrix multiplication in this by this using this syntax here, using this percentage and then multiply percentage B. So if you run, you can see that A times B, this is the matrix multiplication. This gives us the basically 2 by 2 matrix as we expect. You can try out other examples. So let's do another example. Let's create another matrix here. So suppose I do this way, and I can see that my matrix A and B, this time, both of them are 2 by 2, okay? So if we do the regular multiplication A times B, so you can see that we can still multiply these, but this is the term by term. So we can see A and B. So if we multiply 2 and 3, so the first row, first column, we have 2 times 3, 5 times minus 3, which is minus 15 here. 1 times 1, this is 1. So you can see this is the element-wise multiplication here, okay? But if we use A and then use the percentage times and then again percentage B, so this is the matrix multiplication. Okay, basically just be careful about this difference. So maybe it is easy to think that A times B is going to do the matrix multiplication, but actually it doesn't. It simply does this element by element multiplication in R. Okay, that's the syntax here. Finally, we can also introduce the matrix inversion. Okay, so basically if we have matrix A times the inverse of A, right, what we get is the identity matrix. We know this from linear algebra. So again, we can see this with an example. Suppose we create this time the matrix and we input some vector of elements to our matrix 3, 4, let's say 1 and 2. And we specify the number of rows, let's say 2, and number of columns equals to 2. So this is our matrix A, just an arbitrary example here. And we can write solve A to get the inverse of this matrix. And we can see this is the inverse So this is matrix inversion in R. Okay, so basically we completed the discussion in matrix operations in R. Now we can start to talk about more on the arrays in R and doing some array operations. So first of all, we can create an array using this array function, and we can input some data. Let's say I want to input some sequence of numbers, just like the matrix function, but this time in the array function, actually we are not restricted by the 2 dimensions. Okay, so we can create a higher dimensional array. So for example, 3 by 4 by 2. So now I have, as given here, we have a sequence of 24 elements from 1 to 24. So I'm going to basically fill these 24 elements into the different matrices that I will create. So basically, you can think this as 3 by 2 matrix, but we have 2 matrices. Okay, we have a sequence of matrices. So 3 by 4 we have 12 elements, and if we have 2 matrices, so total we have in total 24 elements. Okay, so we can check our array that we create. So this is like our first matrix, and we have another matrix here where the elements are from 1, 2, 3 all the way to 24. Okay, we can create another array. Let's call this as BR. Again, let's use the array function. Now, again, I'm going to assign some data to fill in my array. So this time, let's say I want to repeat the sequence from 1 to 24, and I want to repeat it 3 times. Okay. Now, I have more elements, as you can see. This 1 to 24, this is repeated 3 times. So I can actually add one more dimension to my array. So just like the previous example, but this time I'm going to have 3 of those, right? So I have one more dimension added, and we can see the result. Okay, so you can see we have much more number of, we have a higher number of matrices here that are displayed, right? And of course, each time we display here, it is 2-dimensional, but you can see the index. Okay, this is the 1, 1, 2, 1, 1, 2, and so on. Okay, all the way to 2, 3, which is the maximum dimension that we gave here. So we can use the arrays if we want to create such multi-dimensional objects, to store our information or the vector of numbers that we want to store. We can use the arrays as a higher dimensional object. And just like what we did in the matrices, we can access to subsets, we can do extractions or replacements in arrays as well. So for example, if I want to access our array AR, the first is our first dimension 2, and then we can, let's say, access to this guy, this index. If we skip the middle one, that will extract all the elements, with the second dimension from 1 to basically 4, right? For the second dimension, we have defined 4 elements. So from 1 to 4, all of them will be included. So we can check this. So this is the subset of our array that we can access using the index. Okay. You can create other examples like let's say 2, and we can use another vector of values, let's say 3 and 1, and then we can take 2. So this time I don't have to just take from 1 to 4, I mean by omitting this second index. Instead of omitting this second index, I can specify the exact index numbers like 3 and 1. I want these maybe, so I can run. So you can see the third index equals to 3 is 20, and then for 1 you get 14. Okay, so you can specify the specific index location of the elements that you want to extract. Or alternatively, you can just leave the other two empty, so this will give you, for example, it will set the first index equals to 1 and retrieve all the other elements that corresponds to index equals to 1. And again, similarly for the other array BR, this time you notice this says 4-dimensional. It's 4-dimensional, so you can specify the index number as you like. For example, this can be 1, 2, and 3, let's say. Okay, so if I run this, it gives me a specific number because I specified all the index values. But if I want to take more, not a single value, for example, I can set index 1 equals to 1, and then I can take the others, and then I can set this one. Okay, so we have the middle two dimensions, we just take all of them, we set the first and the last index equals to 1, and this will return us a matrix. Because this is a 4-dimensional object, if I set these two values, then I'm going to get a matrix as we expect. You can think of other examples. Again, just you can practice on your own as well. You can also just create a sequence of numbers here. Let's say this is 3 and 2, so you will use those two index values for the first dimension. For the second dimension, let's say I want to set index equals to 4, then we leave the 2 empty, so this is going to give me two matrices with the first index equals to 3 and 2. Okay, and let's do one more example and then move on. So for example, here let's say you have 1 and empty, so this time the first and the third indices we set equal to 2 and 1. Again, if we set two indexes to a specific number, remember we will reduce, this is a 2-dimensional now result because it's going to be a matrix. But if you leave one more empty, for example, or you can say 1 and 2, this time, as you see, we get these sequence of basically matrices. So you can change these as you like. I mean, you can experiment with these, and you can see how the results change. Okay, so I think we can stop here for this video, and then in the next video we will continue with non-numeric values in R. So thank you for watching.